So I think in the very first lesson that we did in functions, you saw this, which is the general form, but really we're just used to seeing, actually I'll just show you this one. We're used to seeing just stuff like this. So what is the degree of a polynomial? And in this case, the specific one, what's the degree? 4. How do you know that? With highest exponent, that's it. Boom. Leading coefficient? 1. It's the number in front of the variable with the highest exponent, in this case, 1, because there's a 1 in front of that. Constant term? 5, the one with no variable. Boom. All right. Okay, basically, what is a polynomial? What is not a polynomial? The biggest thing is you cannot have roots, okay, of variables, negative or fractional exponents, okay? And that's why roots are not 1, because when you have a root, it's a fractional exponent. Or any coefficient which is a non-real number, i.e. square root of -1 or square root of negative, things like that. Not real numbers. Those are called imaginary numbers, but they are not polynomials if you have any of that. So in the first one, is it a polynomial? Why? Yeah, because of that. No. Second one. Nope. Because of the negative, right? What about C? Polynomial or not? Why not? Yeah, but what's the root on? 17. So that's a real number, right? You just can't have it on the variable. So this is a polynomial. What about D? No, because you have the root on the variable, which is going to give you a fractional exponent. So that messes it up. Nope. E? Think about it. Yes or no? Yes, it is. Because if you rewrite it as root 3 x2 to the power of a half, what happens to the exponent? It becomes 1. It is a polynomial. And the last one, yes, no. Why not? Yeah, can't square root that. It's a non-real number. Unreal. Okay. Flipping the page. We're not doing that. Normally we would. We're not doing that. Normally we would. All right, the bottom of the page. Consider the polynomial function p of x is equal to 7. Why does this have a degree of 0? Anything to the 0 power is what? 1. So I could write this as, do we agree with that? Is that the same thing? Yes, because that x to the 0 would be 1. So when you have a constant function, i.e. one with no variable, it has a degree of 0. Hence called the constant function. We're just motoring through this. I'm not going to test you on any of this. This is just sort of a, I mean, you should know how to pick out the degree and stuff like that, but classifying, we can classify them by degree. So the degree of this first one here is, if c is a constant, is what? 0. What's the degree of the second one? 1, right? Third one? 2. Fourth one would be 3. And that one would be 4. Okay. Now, how do we call these? They have specific names. So the first one, we just looked at it, is called a constant function. And that is because it's x to the 0. They look like this. They are horizontal lines at whatever the constant is. guess I should put that in for C. What about the next one? AX plus B, what type of line is that? Linear. And so that's your grade 10, that kind of stuff. So we can call this, it's grade 10. What about the next one? Quadratic, which is grade 11. Quadratic. And so we know that they are parabolas opening up or down depending on the leading coefficient. So the second one we can say is x to the 1. This is x to the 2. What's the third one called? Cubic. If it's a third degree, it's called a cubic. Thanks, Matt. Cubic. And this is what we're going to study in this one. And the fourth one is called a quartic, if you want to get fancy. And then after that, they basically just call them polynomials. Even after 3, they just say polynomial. You know what poly means? It means many. So cubic graphs, as you will see, look like that, or they can be flipped as well. We'll play with those. And quartic graphs, anybody know what a quartic looks like? A fourth degree? Can look like a W or an M if you put a negative in front of it. Or it could even look like a quadratic. It's just x to the 4, and that's all it is. It'll look just like a quadratic, just rises faster. But we're going to study all those, so we don't have to worry about them right now. I usually go through these. Let's just do it quickly. 5, 6, 7, 8, 9, 10. Anybody know what a fifth degree polynomial would be called? 4 is quartic. Anybody know what 5 is? Quintic. Anybody know what 6 is? Sextic. 7? Septic. That is it. If you think of, I wrote 6 twice. 7, 8. If you think of chemistry, what would 8 be? Octopus. 9? Sorry. 6 is sextic. 9? Anybody know what a 9-carbon backbone is in chemistry? Nonane. So it's nonic in math. I'm not going to ask you these. You might see these words. 10. Decic. All right. Yeah, we're skipping all that. You can call them, I'll just say it. You can call them integral polynomials, in which case every variant or every coefficient is a whole number. If you call them rational polynomial functions, you can have fractions as your, you say a rational number, it's basically talking about fractions, okay? Or you can call it a real polynomial, in which case all numbers are real numbers. You can have decimal leading coefficients, you can have all these different things, but we're just going to call them polynomials. All right. We'll do this one question and then this lesson's over and we'll do long division after. You're all excited for long division. All right. If P of X, they just call it P of X instead of F of X because they're just trying to be fancy and just say it polynomial X. Negative 3x squared plus AX plus 8. And they tell us that P of 1 is equal to negative 9. So let's just look at this thing here for a sec. The 1 and the negative 9 represent X and Y. One is which? 1 is X. Whatever's in the brackets is X. Just like that. So what this is saying is if I put X is equal to 1 into this polynomial, what do I get? You get negative 9. That's your Y value. Or P of X. So all you do is You do that, and then you'll have an unknown a, and you can solve for it. So if I put 1 in here, I get -3 times 1 squared. A times 1 plus 8, all of that should equal -9. And then you just algebra it. 1 squared is 1, so -3 plus a plus 8 is equal to -9. -3 plus 8 is 5. 5 over a is equal to -14. Is that okay? All right. This lesson is over. How long was that? 15 minutes? Normally I'd give you a couple questions, but I'm like, not super important for this. All right, we're gonna do lesson 2, which is long division. Okay, page 391, long division. So, sometime in your mathematical careers, you would have done something like this, I hope, where you have a single denominator with a big polynomial up top. And if you have a single denominator, it goes to each term up top. So you can rewrite it as 15x cubed over 5x minus 10x squared over 5x plus 5x over 5x. Because if you're going the other way, you need a common denominator, and then you just add the tops, which would give you this thing. Okay? So then we just simplify it. What's 15 divided by 5? 3. X cubed over x is x squared minus 10 divided by 5 is 2. X squared over x is x. 5x over 5x is 1. So if you have a single denominator, a single term in your denominator, by term I mean like just 5x. If I wrote 5x plus 1, that's 2 terms, because a term is separated by a addition or subtraction sign, okay? So then the 5x plus 1 changes things, and that's what we're going to look at today, or in this lesson. All right, we're going to skip this. We're going to come back to this PDQR stuff in a sec. We're going to go way back. I don't know when you first learned long division. When do you learn long division? Yeah, like grade 6? Grade 6? All right, people, we're going back to grade 6. 6 years ago? 7 years ago? I don't know, whenever. All right. What are we going to do here? We're going to divide 5,773 by 25. Okay, so we're essentially doing this. 5773. There's a couple ways you can write it. You can write it like that, or you can write it as a fraction like that. Either way, when you do the long division, the number you're dividing by, which is called the divisor, pretty fancy name, goes on the outside. You draw this, I don't even know what this is called, division sign. It's not a square root sign. The number up top, the numerator, might as well use the correct terms, goes inside. All right, who remembers how to do this? What do? So you take the first two numbers, 57. Okay. What times 25 gets close to 57 without going over? 2. So you put the 2 right above there. Then you go 2 times 25 is 50. Good job, peoples. Then what do? You subtract them. So you get 7, right? Then what do? You drop the other 7 down. Draw a little arrow. And we do it again. 25 into 77 goes how many times? 3 times, right? You can't go over. So I put a 3. 3 times 25 is 75. Subtract them again. You get 2. Bring down the 23. Does 25 go into... No, it does not go into it, right? I was thinking of something else. You could do 0, blah, blah, blah. You would get 0. Subtract them, and you get 23. And there's nothing else to bring down, right? We're essentially at a decimal. Everybody agree with that? Okay. What do you call this number down here? The remainder, hence the R up here. Look at it, it's all coming back, isn't it? This is called that. I'll fix that 23. So that 23 is your remainder. Okay, so now let's look at this stuff here, and then we'll look at how to write it up here. So for Math 12, I'm going to ask you to write everything as dq plus r, Dairy Queen plus your remainder. Okay, this is what I'm going to want you to do. There is another way to write it, which is like this, which is useful in calculus. Believe it or not, we actually do this in calculus. Because what this allows you to do is rewrite it, and now we're going to do it with polynomials, we're not going to do it with numbers. It allows you to rewrite this expression as something else. So for example, I can rewrite 5,773 divided by 25 as d, what's my divisor? The number you're dividing by, which is 25, times the quotient. Now the quotient is this thing. This is your Q, quotient. Okay. Times that plus your remainder, plus 22. So if you multiply 25 times 230 and added 23, you would get 5,770. They're equivalent expressions. Okay. Now this is with numbers. We're obviously not going to do it with numbers. We're going to do it with polynomials. Okay. So everybody good on that little grade 4, 5, grade 4, 6? Okay. Right. We're good? Okay, let's do it with polynomials then, peoples. Okay. I really don't like it when they do all this stuff. So let's do the last one here. Nope, let's do, sorry. We'll do this middle one, but yeah. All right. Here we go. Oh, why would you? It's a dumb question. Whatever. Okay, the x goes on the outside because that's your quotient, right? Or your divisor, sorry, my mistake. Q, that is your quotient, sits on the outside. What you're dividing by goes, or what you are dividing goes on the inside. However, look at the exponents here. X cubed, then 5x. You need the exponents to go down by ones. So you need an x squared in there, okay? They have to go down in order, right? You can't skip an exponent. So we need an x squared. So I can add one in by putting a 0x squared. That doesn't change anything. And then I put minus 5x, and I put plus 6. All right, are you ready? Okay, so what you do is you start with the x, and you go, how many times, or what do I multiply this x by to get x cubed? Sorry? X squared, right? If I multiply by x squared times x is x cubed. So that sits there like that. Then what do? Just like what we did in the previous one. You subtract them. So let's subtract them. X cubed by x cubed is nada. Bring down the 0x squared. This is a bad example because you don't actually need it, but that's okay. And then you ask yourself, what do I multiply x by to get 0x squared? 0x. Okay, or 0. But we'll put 0x because that'll make more sense later on. And then you go 0x times x is 0x squared. And you subtract them, and you get 0. And you bring down the negative 5x. You must bring the sign with it. Okay, so don't forget the negative up there. You're going to bring that down. And you go, okay, what do I multiply x by to get negative 5x? Negative 5. Right? So this is negative 5. And you go negative 5 times x, negative 5x. Now, if you're subtracting these, that sign flips, and so it's negative 5 plus 5, which is nothing. Bring down the 6. Can I multiply x by anything to get 6? No. So 6 is your remainder. X is your q, and this thing, x is your divisor, and that thing is your q. Quotient. So if you're going to write it as p is equal to dq plus r, divisor is x. Quotient is x squared minus 5. I'm going to leave out the 0x. And the remainder is 6. All right, let's do one that involves a little more here. Is there any questions about that? All right. Now, we're going to do it with a binomial, which is what you would use this for. We have 2x squared minus x minus 18 divided by x plus 2. All right. So we write the x plus 2 on the outside because that's our quotient. What do I keep saying? It's the quotient. It's the divisor. D. Sorry. D. I'm going to write it in a different color. Divisor. It's what you're dividing by. Okay. Now, when you have a binomial, 2 terms, you take just the x is the only thing you look at, and you go, okay. Or the other thing, sorry, do the exponents go down in order? Yes. If they don't, it doesn't really work out. You have to go back and fix it. So you'll see it in one, and I'll show you if you don't do that. So they go down in order, so just write it. So you go x, what do I multiply x by to get 2x squared? I've already done it for you. It's 2x, right? So then I go 2x times x is 2x squared. And you have to go 2x times 2, which is 4x. Is that okay? All right. What do I do with these two terms? What are you always doing? Subtracting. So I subtract it. Put it in brackets, please. I mean, I'm not going to take marks off if you don't, but people can get confused about signs. So 2x squared minus 2x squared, that should go away. Okay, you want that term to go away. Negative x minus 4x is negative 5x. And then you do it again. You just look at this x and you go, what do I multiply x by to get negative 5x? Negative 5. Negative 5 times x is negative 5x. Negative 5 times 2, negative 10. Bring the 18 down. Put it right there, because then it all lines up. If you subtract these, what do you get? Negative 8. Because the 5x's will go away. Negative 18 plus 10 is negative 8. That is your remainder. So then we say P is dq plus r. Divisor, what you're dividing by, is x plus 2. Quotient is the thing up there, just 2x minus 5. And the remainder is negative 8. And that's it. All right, I have one more to do. Then we're done. Okay. Is there any questions? All right. This one here. Divide y cubed minus 6y plus 20 by y minus 3. All right. So, first thing, do the exponents go down in order? No, we're missing a y squared. So we have to add that in. So it's y cubed plus 0y squared minus 6y plus 20. And we're dividing by y minus 3. Okay. So you ask yourself, how many times does y, forget about the number, the negative 3, just it's y. What do I multiply y by to get y cubed? Y squared. That goes above here. And then you multiply y squared by y to get y cubed. Y squared times negative 3. There you go. And then you subtract them. What happens to the y cubes? They go away. 0y squared minus negative 3y squared. 3y squared. Bring down the negative 6y. Then, what do I multiply y by to get 3y squared? 3y. Then you multiply by both again. 3y squared minus 9y. And then you're going to subtract them again. What am I left with here? 3y. Bring down the 20. How many times does y go into 3y? 3 times plus 3. Then I got 3y minus 9. Subtract them again. So it gets a little tedious. And I'm left with 29. What is that number? That's your remainder. What's your quotient? Yeah, this thing, right? Q. This is your divisor. They would say write it as P over D, Q plus R over D. We'll just save that for calculus. Just write everything as DQ plus R. So this polynomial is now, what's my divisor? Y minus 3 times y squared plus 3y plus 3 plus 29. that okay? All right, I'm just gonna give you a few questions and we're done. Let's do number 1 and 3.